Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7 Learning Target 12. So we're going to be talking about dependent probabilities. So on the previous note here we talked about independent, and that's where the two events did not affect each other. Well, guess what? Today they're going to. So dependent events are when the result of the first event is going to impact the second. So for example, if I draw an ace out of a deck, and I don't put it back, when I go to draw the 4, there's going to be one less card in the deck because I didn't put it back. So independent is where the two events do not affect each other, and dependent are when they do. So make sure you get this written down because that's going to be important for you guys to remember in the future. All right, so let's take a look. And just as a reminder, remember that and means you need to multiply. So that's something that we're really going to be focusing on this unit. And means multiply. So 3 cards are drawn from a standard deck of cards without replacement. Find the probability of drawing a heart, another heart, and a spade in that order. Okay, so here's one big thing right here where it says without replacement. You immediately know that it's going to be a dependent event because we're not replacing those cards. So let's go ahead and let's take a look at that. So to start off with, the probability of drawing a heart. Well, when we first start out, there's 52 cards in the deck. Then there's 13 hearts. So now we're going to assume that that happened, that we drew out our heart. Because if that didn't happen, this probability is over and there's no point in continuing. So we're going to assume that we did. So if we did, there's one less total card and there's also one less heart in the deck. Then we're going to assume that that happened again. And now we want to find a spade. So then how are we going to find a spade? Well, we're going to have one less total card in the deck, but so far we assumed that the 2 cards we've pullen out to this point have been hearts. So that means we still have 13 spades in the deck. So the only difference today is we just have to be thinking about what we did previously. So now let's go ahead and multiply. So 13 times 12 times 13. That's going to give you 2,028. When you multiply all that across, then you're going to do 52 times 51 times 50, and that's going to give you 132,600. Then you're going to go ahead and you can divide that in your calculator, and you end up getting 0.02. Maybe be calculating this along with me. Remember, you want to be very careful about your probabilities, okay, and your rounding when you do that. So next, let's take a look at number 2. So number 2, there are 3 miniature chocolate bars and 5 peanut butter cups in a candy dish. Liz chooses 2 of them at random to eat. Let's be honest, if you take out a miniature candy bar, you're going to eat it. Okay, you're not going to put it back in because chocolate's delicious. So we have 3 and 5. So there's 8 total candy bars, and 3 of them are miniature chocolate bars. Well, Liz is going to draw one out, and gosh darn it, she's going to eat it. So that means that there's one less candy bar in the whole total dish. There's also one less mini chocolate bar because she ate it. Okay, so now we're ready to go ahead and multiply out these probabilities. So 3 times 2 is going to give you 6. 8 times 7 is going to give you 56. So then you can take 6 and divide it by 56 and you get 0.11. So there's an 11% chance that she draws out 2 mini chocolate bars in that. So not very likely, but it could still happen. Let's take a look at number 3. In the state lottery game, the cages contain 10 number balls. Sweet, that's my total, no more thinking. Okay, the balls are labeled 1 from the digits 0 to 9. What is the probability the first 2 balls are drawn are odd and the third will be prime? So let's think about it this way. So there are 1, 3, 5, 7, and 9. There's 5 odd numbers. So we have a 5 out of 10 chance of drawing an odd number. So we're going to assume that that first round we drew an odd number. So that means there's 1 less number here and 1 less odd number there. Okay, so then when we want to figure out if there's a prime, we're going to assume we drew out an odd number. So there's 8 left, and then there's only going to be 2 prime numbers left after that because the prime numbers are 2, 3, 5, and 7. So some of them could have been drawn in that odd pile. So now we're going to go ahead and multiply across. So we have 5 times 4 times 2, and that's going to give us 40. And then 10 times 9 times 8 is going to give us 720. So you're going to take 40 divided by 720, and that's going to give you 0.06. So there's a 6% chance that the balls will be drawn out, and that will be what happens. All right, let's take a look at this one. Find the probability of drawing 3 cards of the same suit without replacement. So here's the thing. When we start off with, we have 52 out of 52 because we haven't decided what suit we're going to draw out yet. We can draw out any card, and that's the suit that we're going to stick to. So once we've drawn it out, now we only have 51 cards, but we want to get it in the same suit as the card we already picked out. So since we want it to be of the same suit, now there's only 12 left of that suit because we drew out one of the suits right there. So now we only have 12 left, and we also only have 51 left total. Again, we're going to assume that we draw one of that suit out again. So now we only have 50, and we only have 11 there. So now we can go ahead and multiply across the top. So 52 times 12 times 11. That's going to give us 6,864. And then 52 times 51 times 50, you can multiply all of those together, and you're going to get 132,600. So now you're going to take, and you're going to do 6,864 divided by 132,600. And when you do that, you end up getting 0.05. So even though we left it open, we said you can pick any suit you want, but after that you have to get the same suit. Even though we did that, there's still only a 5% chance of that actually happening. That's crazy, right? So let's take a look at number 5. So for number 5, Miss Humber's handing out Dum Dum suckers. I do that a lot, you know. I just got my new big bag. So you and your friend Shirley like strawberry. Miss Humbert has 3 strawberry and 7 other kinds. Okay, well that means we have 10 total. What is the probability that you and Shirley get a strawberry sucker? So the probability of you first getting a strawberry sucker is 3. So first I'm going to hand it to you. And then that and, remember, means multiply. I'm going to go to Shirley. Well, when I go to Shirley, I've already given you a sucker. So I only have 9 left in my hand. And we're going to assume, for this to continue, that I gave you a strawberry sucker. So now there's only 2 strawberry suckers left. So now we're going to multiply across the top to get 6. And multiply across the bottom to get 90. So our probability is 6 divided by 90. And when you divide that out in your calculator, you end up getting 0.07. So that means there's a 7% chance that I give you and Shirley strawberry suckers out of my 10. Next, let's take a look at number 6. There are 26 candies in a bowl. 6 are Starburst, 10 are Snickers, 10 are Reese's. What is the probability that Miss Hummer draws a Starburst, eats it, ew, but this time I have to eat it, and then draws a Reese's. So this time we're going to assume that I'm eating it. So we want to count. We have 26 total, and 6 of them are Starburst. So I'm going to assume that I drew out that Starburst. Well, when I drew out that Starburst, that means I have 1 less candy in my dish. But because I drew out a Starburst, it doesn't affect the number of Reese's that I have. I still have 10 Reese's. And now I can multiply across the top. So 6 times 10 is 60, and then 26 times 25 is 650. So I can go ahead and I can divide those out. 60 divided by 650 is going to give me 0.09. So that means there's a 9% chance that I draw a Starburst and then I draw a Reese's. Okay, so let's take a look at a couple of these. So we want to decide if they are dependent or independent. So if we're talking about choosing, remember, independent means that the 2 events don't affect each other at all. Dependent means that they do. If we're talking about choosing a color and a size of pair of shoes, the color is not going to affect the size. Those are 2 different things. So this one's going to be independent. Next, let's take a look at this next one. Choosing a winner and a runner-up of a dog show. Well, think about it this way. If you're going to choose a winner, once you've chosen a winner, there's only so many people left that you can choose from because you're losing one person because they're the winner. So that makes that one dependent. Taking a look at number 3, choosing a president, vice president, and secretary and treasurer for student council, assuming that each person can only choose one position. So once we choose the president, I have one less person in the running for the secretary, and so on down. So this one is dependent because you can only hold one position, and once I choose one, there's less choices there on down. Next, selecting a fiction book and a nonfiction book at the library. Well, do fiction books and nonfiction books relate? No, so that makes this an independent event. So that one is an independent event. So that concludes your note video today. Go ahead and show me your completed note sheet once you're done. Thanks for listening.